Hey everyone, we're back and today we're going to be working on worksheet 2B, problem 9C. Alright, so let's go ahead and dive right in. The problem says the density of liquid mercury is 13.5 grams per milliliter. For the following amounts of mercury, convert the masses to volumes or volumes to masses. So we're looking at this one right here. So the given information is 55 milliliters, and that is a volume. Let's go ahead and write that here. So I'll be interested in converting that to a mass unit. So the question is, what mass unit might we convert to? And we can decide that in the end, but some typical mass units that we might be converting to are grams or kilograms. Those are by far your most common, or milligrams. You notice it's all based on sort of grams. That's usually what we're working with in chemistry because it's the typical metric system unit for mass. Okay, so then there was one more piece of information given in the problem, and it's 13.5 grams per milliliter, and we can sort of choose whether to put that here or here. I sort of know what we're going to use it for, so I might default to putting it there, but since you don't know yet, maybe, then we'll go ahead and write it over here as given info in the problem, grams per milliliter. Now the reason I know that I'm going to probably use it as a conversion factor is because it's a ratio unit. So in chemistry, you're very, very often using these ratio units as conversion factors, and you can sort of see that in there already, that we have 55 milliliters of mercury and we're trying to convert to a mass in grams. This is the ratio between those two units, between milliliters and grams. So that's what we'll go ahead and use. We can rewrite it over here actually as an equality if you want to look at it a different way. What we're saying when we have this ratio here of density is that 1 milliliter of the mercury is equal to 13.5 grams. For mercury, 1 milliliter of it in volume would weigh 13.5 grams. So we can look at the two pieces of information in the problem. We can say that the number of sig figs, the least number of sig figs is 2. So if we need to use that, we can. Is this primarily a conversion problem? Yes. Would drawing a diagram help? Personally, I don't think so. Is a chemical reaction occurring? No. So we can go ahead and get started. We're going to start out with 55 milliliters, and this will be my plan first. You don't always have to write it out exactly like this with a plan, but I'm going to, because I think it's helpful to think about it ahead of time. I'm trying to convert from milliliters to grams. So to convert from milliliters to grams, I can actually, it seems to me I can do that in one step, because up here I have a direct conversion from grams to milliliters for mercury. So I'm going to use the conversion of 13.5 grams is equal to 1 milliliter for mercury. I should be able to do that in one single step. So now let's go ahead and work out the solution for this. 55 milliliters in this equality, or you could even look at this ratio. Which side of this ratio matches that unit? Well, clearly it's the milliliter side. So I'm going to put the 1 milliliter side on the bottom and the 13.5 gram side on the top. My milliliters will cancel, giving me my answer in grams. Grab my calculator. 55 times 13.5 equals 742.5. 742.5. I'll look back up here. I've seen that I've only done multiplication in this problem, or division, and my least number of sig figs, that was a 3 sig fig number, that was a 2 sig fig number, was 2. So I'll round this to 2 sig figs. 740 grams, And because I want to be really clear, and that zero, trailing zero, it's really hard to remember whether it's significant or not, I'm going to go ahead and put that in scientific notation, which is the best thing to do here in this case. And that's it. Does it seem reasonable that 55 milliliters of mercury would weigh 740 grams? I mean, that seems like a lot, but remember 1 milliliter weighs 13.5 grams, so it's more than 10 times as many grams as the number of milliliters. So yeah, that seems about right. And grams was a unit of mass. That was what I was looking for, so that works out. So yes, it's reasonable. Now technically, if you had converted 2 kilograms or milligrams, you would have answered the problem correctly. So that would have worked out fine too.